Hi there! I'm going to show you how to build a game with physics in just minutes using SpriteBuilder. SpriteBuilder is a complete environment for developing high-quality 2D games in Objective-C, and it's cross-platform. Your one codebase runs natively on both iOS and Android. With SpriteBuilder's rich functionality, this means that doubling your efforts will double your features. SpriteBuilder has hundreds of plugins to choose from: resource handling, a tileless editor, a physics engine, particle systems, and much more. So let's get started. First, I need to download SpriteBuilder from SpriteBuilder.com. I'll click on Download and drag it into my Applications folder. The first time you open it, you may need to right-click on it in Finder and select Open. First, let's set up a new project and save it as Flying Feathers. Since I'm making an iPhone-only app, and the assets we have are designed for iPhone Retina devices, I need to change the default scaling in project settings from 4 to 2x. Next, we'll add our resources. Let's make a new folder called Sprites and drag our small assets into it. By right-clicking the folder, we can turn it into a sprite sheet. A sprite sheet packs all your images into a single image, so that it's faster to load and takes less memory on the device. You can also select advanced options for turning your sprite sheets into PBR textures for even better performance. Now we'll set the scene for our first level. Let's create a layer and title it Level, and set the size to 750 by 320. This will make the level a bit larger than our iPhone screen, so we'll be able to scroll it back and forth horizontally. Let's set the class of the root node, labeled CC node, to level. This will allow us to connect the objects we add in SpriteBuilder to our Objective-C code and Xcode. Next, let's add a physics node. The third tab on the left side contains all node types we can add to our scene. We'll drag and drop a physics node and place it under the root node. This will simulate our physics world and add physics bodies to our assets. We'll set the physics node's document root to _physics node. This will make the physics node accessible to our code as a member variable to our level class. Then we'll drag our background image to set the scene, making sure that the background is above the physics node in the hierarchy so that it stays as the background. Now we'll insert a ground underneath the physics node since, even though it is a static object, it'll be a part of the physics simulation. We'll enable physics and set it to static, because it has no dynamic properties such as gravity, friction, and whatnot. Lastly, we'll drag and drop the other sprites into our physics node and enable physics on each of these. Now let's make a cannon to shoot birds from. We'll go to the third tab and drag in a button. Let's delete the title, edit the size to 120 by 100, change the image to our tower, and change the highlighted state to null. Then we'll assign the CC button to a selector titled Launch Bird, and we'll change the target to document root. The document root is our level class. When we press the button in our game, the launch button method of our level class will now be called. Now for the launcher. Drag out the launcher and set the anchor point to the bottom to allow the launcher to rotate around this point. And let's place it behind the button by dragging it above. We want our launcher to throw birds that hit our blocks, so let's make it rotate back and forth. Let's set our timeline to 2 seconds and chain the timeline to itself so we'll have a looped animation. Now to add rotation, we go to Animation, Insert Keyframe, Rotation. We'll move the time marker ahead to the 1 second mark, hold down Option, and set the rotation angle for the first second. Then we'll drag this out to 2 seconds and use the shortcut R on our keyboard to set another keyframe. Then we'll change the degrees to 0 so it will rotate back up. Let's press play and watch it rotate. Nice! Lastly, we'll connect the launcher to our code by assigning it to a member variable on the root node, our level class. Now let's make some birds that will fly out of our cannon. Let's make a new interface file of type CC_sprite and title it bird. With the bird.ccb document open, We'll click on CC Sprite in our node graph and set the sprite frame to our bird image. Then we'll enable physics in the third tab and change the shape to circle. Last thing we need to do in SpriteBuilder is to make our level part of our game. By default, our project will start running the main scene. We don't need to change this, so let's edit the main scene. Let's add a scroll view from the third tab by dragging it down to our hierarchy view. We'll set the content to our level file and disable vertical scrolling. Now we need some code to make the cannon shoot the birds. Let's publish what we've done so far before moving to Xcode. By publishing the project, we make all interface files and image assets available in Xcode. When we created the Flying Feathers project, it automatically created an Xcode project for us, so we'll find it next to our SpriteBuilder project file. We'll double-click to open it up. To hook up the level file we created in SpriteBuilder, we need to create a level class in Xcode. Our level class will be a subclass of CC Node. Let's add some code to our level class. First, let's start with the header file. In SpriteBuilder, we added member variables that should hook up to our level class, so we need to add these variables in our code. We have the physics node and the launcher. Next, we'll need to add some code to handle when we press the launch button. We added a selector to the button in SpriteBuilder, so we'll need to add that to our code. Let's create a new function and name it launchBird. To be able to send our bird in the direction our launcher is pointing, we need to get the rotation of the launcher at the time when we press the button. As we've created a reference to the launcher, we can access it right in the code. Let's read the rotation property of our launcher and convert it to radians. Using some simple trigonometry, we can calculate a direction vector for the rotation. Let's use this direction vector to place the bird at the tip of the cannon when it's launched. By multiplying the direction vector, we get the offset from the launcher's anchor point. Now let's create a bird. We create a new instance of our bird by calling the ccbReader method nodeGraph from file and loading the ccb file with its name, bird. This gives us a new instance of a bird. We set the bird's initial position and add it to the physics node. The only thing left to do is give our bird an initial speed when it's leaving our cannon. We do this by applying a force in the direction of our direction vector. Now let's run it and play our new game. And that's all it takes to get a simple physics game up and running with only a few lines of code. Powered by Cocos 2D, the most popular open source game engine for mobile, and the open source Chipmunk physics engine, SpriteBuilder is easy to extend and customize. So go to SpriteBuilder.com and get started now. Thanks for listening.